This is a screencast for section 10.1, example 1, parametric curves in the plane. So you studied parametric curves last year in pre-calc, and we're going to do a little bit of review first before we dive into the calculus part. In example 1, reviewing some parametric curves. We want to sketch the parametric curves and identify those which define y as a function of x. In each case, eliminate the parameter to find an equation that relates x and y directly. Okay, so for A, it tells us that x, the horizontal motion, is going to be the cosine of time, and then y, the vertical motion, is going to be the sine of t, or time. And then we want t to be between 0 and 2 pi. So usually this does mean time, but it could mean anything. It's just t, it's your input variable. Well, I know that there is a relationship between cosine and sine, a trig identity that I'm very familiar with. I know that cosine squared plus sine squared equals 1. Well, since x equals cosine squared and x equals cosine and y equals sine, I can then make that substitution. So x squared plus y squared equals 1, which has the equation of a circle with center 0, 0 and radius 1. So that leaves us with this graph down here. Now that is not a function, so we do not need to identify it as being y a function of x. Part B. X equals 3 cosine of t and y equals 2 sine of t. Well, I have this cosine and sine thing again. So I do know that relationship of cosine squared plus sine squared equals 1. But first, let's solve for cosine of t. Cosine of t is going to be x over 3. Sine of t is going to be y over 2. Which that means, since cosine squared plus sine squared equals 1, I have x over 3 squared plus y over 2 squared equals 1. That's the equation of an ellipse whose long horizontal axis is 3 and whose short axis, vertical, is 2. Again with center 0, 0. And again, also not a function, y is not a function of x. Part C. X equals square root t and y equals t minus 2. Well, this doesn't involve trig, so I'm looking at this thinking maybe substitution might be a good idea. I want just x and y's, so if I solve the x equals square root t for t, I can plug in x squared then for the y function, and I get y equals x squared minus 2. Now it only wants t for the intervals 0 to 4 because we can't plug negatives into the square root for this x parameter here. So 0 to 4 for t gives us 0 to 2 for x, so that's how you see the domain here is 0 to 2. And then the y values go from negative 2 to positive 2. This is in fact a function of x. Then I'll try problem number 1. Says sketch the parametric curves and identify those which define y as a function of x. In each case, eliminate the parameter to find an equation that relates x and y directly. Well, I have a choice. I can eliminate the parameter t and then graph my result as a y equals something with x's, or I can graph this parametric function. I'm going to choose to graph the parametric function first, and here's why. Now when I get to my answer, I can check. My answer is supposed to be, once I eliminate the parameter, is supposed to be a linear function. Looks like a positive slope, y-intercept maybe negative 9-ish, so let's check that out. Again, I have x as a function of t, y as a function of t, so if I solve x, the x equals 2t plus 3 for t, now I can substitute that expression in so for the t and y. So y equals 4 times that expression minus 3. So now y is in fact a function of x. Do a little bit of simplifying. And yeah, I get y equals a line with a positive slope, specifically positive 2. Y-intercept negative 9. So that is a function of x.